Let's start at the top of the dashboard with the power flow diagram. Here you can see how energy is moving through the system in real time, from solar to battery, from the battery to the load, and from or to the grid. Now let's scroll down to the summary page. This view shows the last 24 hours of data in one single graph we call the operational summary. As I hover over the graph, you'll see the breakdown: load, solar generation, battery charge and discharge, plus utility consumption or rollback. And of course, you can zoom in on any section for a closer look. At the bottom, you'll see equipment cards. These are fully configurable for each site and show live data for every piece of equipment or metering point. Next, let's move to the Historical Data tab. Here we can add tags from any equipment for any time frame. Same as the operational summary, you can zoom in and clear the zoom. We can also add a second chart at the bottom, so we can run two comparisons side by side. We can click on Download CSV to retrieve the data on the graph in CSV format. Now let's check the Alarms tab. This shows all active alarms for the site. In this case, there weren't any, so I unchecked the filter to show past alarms as well. Clicking an alarm brings up its history, lets you add notes, or acknowledge it. And finally, the Query tab. This lets you search for a specific alarm, tie it to an individual piece of equipment, and narrow it to a time window. It's a powerful way to track events quickly. All right, now let's look at the Equipment tab. Here we can see live data points from each PCS, battery, meter, AC-coupled PV inverters, or any DER, essentially a real-time view of site operations. Next, the Reports tab. Here I'll generate a delivered energy report. Once it runs, it automatically emails the user a PDF copy. We also have the custom report option. With this, you can pick specific tags, select the time frame, and generate exactly the report you need. Here in the Control tab, we get a quick overview of how the site performed throughout the day. Below, the battery and PV energy dispatch sections. And at the bottom, the summary table shows time of use energy data, daily charges, and NEM credits, giving a full picture of site performance and cost impact. Now onto the Users tab. This is where you can invite new users or add existing ones. Just fill out the form, assign permissions, and they're added to the system right away. Next is Notifications. Here you can search possible alarms and configure alerts for users. These notifications can go out by email or SMS, making sure the right people are notified at the right time. Now let's take a look at the Fleet Management page, sometimes also called the Portfolio view. This dashboard gives you a high-level overview of all your sites in one place. At the top, you'll see filters for region, customer, or site type, making it easy to focus on specific locations or portfolios. Each site card displays key data such as the current state of charge, PV generation, power flow, and any active alarms. You can quickly identify if a site is charging, discharging, exporting to the grid, or idle, all from this single view. You can also click on any site to open its detailed dashboard and review live data, trends, or alarms for that location. Now let's explore the Schedule Builder, one of the most powerful automation tools in the Keystone portal. This feature lets you plan how and when your site charges or discharges automatically. To start, we click Create New Command. Here, we give the schedule a clear name and description, something that makes it easy to identify later. Next, we set the start and end time. You can define exactly when this command should begin and end. There's also a repeat dropdown that lets you choose how often the schedule runs, just once, until specific date, or indefinitely. Now we select a strategy. There are three main options. Fixed output keeps the site at a constant power level. Demand reduction charges and discharges automatically to stay below your demand limit or above your charge threshold. And maximize PV uses as much solar energy as possible before drawing from the grid. For each command, you can also define operating constraints, like the maximum and minimum state of charge or the maximum and minimum kilowatt percentage of the inverter. In this example, we'll use demand reduction. We'll set charge and discharge thresholds to keep the net load within range, helping avoid demand charges. Once the command is saved, it appears in the calendar view. When no active command exists for the current time frame, the system follows the default command. You can set it up the same way as any other schedule, choosing a strategy like fixed output, demand reduction, or maximize PV to define how the system behaves by default. You can quickly see what's active when it starts, and how long it runs. The schedule builder makes automation effortless. You set the rules once, and the system takes care of everything automatically.